Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acidity of phenols is determined by the stability of the phenoxide ion formed after loss of a proton. Electron withdrawing groups, EWG, stabilize the phenoxide ion, increase acidity, while electron donating groups, EDG, destabilize the phenoxide ion, decrease acidity. Moving on to the next step. Analyze option D. First compound, 4-methylphenol, paracrysal. The methyl group, CH3, at the para position is an electron-donating group, EDG, via hyperconjugation and inductive effect. This increases electron density on the oxygen, destabilizing the phenoxide ion, making paracrysal less acidic than phenol. pKa of paracrysal 10.26. Second compound, phenol, no substituent. pKa 9.99 or ~10.0. Since paracrysal, first, is less acidic than phenol, second, the second compound is more acidic than the first. This matches the condition. Moving on to the next step. Check why other options fail. Option A, BrCH2 No2 versus CH3CH3. BrCH2 No2 has both Br and number 2 as EWGs, making it significantly more acidic than ethane. So the first compound is more acidic than the second, not less. The second is not more acidic than the first. Option B, CH3COH2CN versus CH3COH3. CH3COH2CN has both a carbonyl and a cyano group activating the alpha hydrogens, making it more acidic than acetone. So the first compound is more acidic than the second. The second is not more acidic than the first. Option C, 4-acetylphenol versus phenol. The acetyl group, CH3C is equal to O, at the para position is an EWG, which stabilizes the phenoxide ion via resonance, making 4-acetylphenol more acidic than phenol. So the first compound is more acidic than the second. The second is not more acidic than the first. And for the final step. Conclusion. Only in option D is the second compound, phenol, more acidic than the first compound, 4-methylphenol paracrysal, because the electron-donating methyl group reduces the acidity of paracrysal relative to phenol. Therefore, the correct answer is D. Therefore, the correct answer is option D.